Alright, in this video we're going to talk about quadratic equations, and we're going to talk about vertex form of quadratic equations and also completing the square. If you're given a quadratic equation in standard form, and again remember a quadratic equation is a polynomial where the highest power on the x is a 2, so x squared plus 3x plus 8 would be a quadratic equation. Again, the highest power on this one is a 2. Notice also the x has a power of 1, so this is in fact a quadratic equation. In standard form, what we call standard form, there's basically no parentheses and everything's multiplied out. Likewise, y equals 3x squared plus pi times x minus 42 would also be a quadratic equation in standard form. So what we want to do is talk about vertex form. And vertex form is when you write a quadratic equation as the following. There's some number a out front, x minus h quantity squared plus k. So this is going to be what's called vertex form. And the reason why they call this vertex form is because, well, you can read the vertex off from this when you write it this way. So this quadratic equation is going to have a vertex at the point h comma k. Notice even though inside it says negative h, you basically use the opposite sign. So if it was negative 3, the vertex, the x-coordinate would be at positive 3. But whatever the k value is, if it's positive or negative, you use that same positive or negative value. So that doesn't change. And the parabola is going to open upwards if this value a is greater than 0, and it's going to open downwards if this value of a is less than 0. So for example, suppose we have the following quadratic equation already in vertex form, and we'll just graph it real quick here. So suppose it looks like y equals 2 times x minus 1 quantity squared plus, I don't know, how about 3? Okay, this thing is going to have a vertex at the point positive 1 comma 3, and it's going to open upwards because the a value, which is 2, well, that's certainly greater than 0, and that again tells you that it opens upwards. So when we go to graph our parabola, again, this is why it's called vertex form, because you're given the vertex kind of for free when it's written like this. So you go over 1 unit, up 1, 2, 3 units. That's going to be where the vertex is. And remember, the vertex is where the parabola either bottoms out or tops out. And then it's just going to open upwards, opens upwards, and it has that familiar U shape to it. So again, not the best graph in the world, but a rough idea as to what this parabola would look like. Also, whatever the x-coordinate is, notice that this parabola is symmetric about that line. So we would say that the line x equals 1 would be the axis of symmetry for this parabola. Okay, maybe let's graph one more, and then we'll talk about putting these things into vertex form by completing the square. So suppose this one, it was y equals negative 3 x plus 2 quantity squared plus 4. Okay, again for this one, now the vertex is going to be at the point, again you take the opposite sign, so negative 2 comma 4, and it's going to open downwards because of the negative 3. So the only thing that matters in terms of it opening up or down is the number out front, and the only thing that affects the vertex are these two numbers outside. Okay? So the vertex, and this tells you it opens up or down, this number out front. Alright, so again, we can graph this without too much trouble. It says you go over to -2, up 1, 2, 3, 4, and that's where our vertex is going to be. And in this case, again, because of the -3, it's opening down, so we'll just make this thing go down. Let's see. You could even figure out a little bit better, for example, where it's going to hit the y-axis, and maybe let's do that. So it's going to hit the y-axis when the x-coordinate is 0. So if you plug 0 into your quadratic equation, we'll get -3 times 2 squared plus 4. Well, 2 squared is 4, times -3 is -12. -12 plus 4 is -8. So this thing should actually be crossing way far down here at -8. So my graph is pretty sloppy here. So it should cross way down there. And again, that's supposed to be a U. It's certainly supposed to have this parabola shape. Again, forgive my artistry. I'm not the best artist in the world, and I am being a little sloppy on this one, so I apologize for that. But again, that's the basic idea. That's the vertex. The axis of symmetry here would be the line x equals -2. And that's it. So that's the good thing again about having these quadratic equations in vertex form, is that you get, again, the vertex for free. So again, sorry about my sloppy graph. This should be a parabola. So let's talk about completing the square now to put a quadratic equation into vertex form. And I'm going to do 2 of these, but I'm not going to graph them. And completing the square ends up being a very useful trick. For those of you taking calculus, maybe you've forgotten and you're doing partial fractions and you need a little refresher. Well, here's how you complete the square. In that setting, you're using it again to integrate, so we're not graphing, but the tricks are the same. So suppose we're given this quadratic equation, y equals x squared plus 4x minus 3. And we want to put this into vertex form. Okay, so it's definitely a quadratic equation, but it's certainly not in vertex form. So the trick is for completing the square. So completing the square. What you do is you basically put the x terms in a set of parentheses. Okay, that's easy enough. And what you need to do is you have to make sure that the coefficient on the x is a 1. And in this case it is. If not, you have to factor that number out. And in the next example I'll do one where the coefficient on the x squared is not a 1. Alright, so then what you do, this is kind of the part where everything happens. So I'm going to leave myself a little space here and just rewrite everything though as it is. Whatever the number is in front of the x term, probably should have picked a different number here, but that's okay. You take 1/2 of that number. So I'm going to take 1/2 of the number 4, that gives me 2. And then you take this number 2 and you square it. So 2 squared is positive 4, and that's what's going to go back inside of the parentheses. Okay. Now we have to be careful though, because if we were to get rid of the parentheses, we would have an x squared, a plus 4x, a plus 4, and a minus 3. But if you look back at the original, there was no plus 4 in there. Okay, everything else was in there, but we've basically just thrown a plus 4 into this problem out of nowhere. So to keep the equation balanced, you can either think about adding 4 to the left side, or equivalently, you could just simply subtract the 4 from the right side. Okay, so this is the tricky part to completing the square that kind of throws people off again. So you take half of the number in front of the x, you square that number, you throw it back in the parentheses, and this is a special case too because notice there's no coefficient out in front of the parentheses. Well, there is, it's a 1. But when the coefficient is a 1, whatever number you add inside, you also subtract it. And the point is now, you can actually write x squared plus 4x plus 4 as x plus 2 times x plus 2. Well, negative 3 minus 4 is negative 7. And I can now write this as x plus 2 quantity squared minus 7. And this is now in vertex form. Okay, so this is the trick. Completing the square will help you put things into vertex form. Okay, so notice how it looks like this form we had at the very beginning. It says you need a number out front, there's an x plus or minus some number squared, and then some number hanging out. Well, that's what we have here. You could think about the a value in this case as being 1. And now it looks a lot like that. Okay, again, I'm not going to graph it, but the vertex of this quadratic equation would be, in this case, at negative 2. You take the opposite sign, negative 7. Let's do one more completing the square problem here, where the coefficients aren't quite as nice. And again, I am going to make my numbers work out sort of nicely. You may end up with fractions that you have to square, all kinds of weird things can happen with the numbers, but that's okay, the procedure stays the same. So suppose we have 2x squared plus 12x minus 4. Okay, I'm going to do the same thing as before. I'm going to group my x terms together. So the 2x squared plus 12x are going to go together. My minus 4 is just hanging out. We want the coefficient on the x squared to be a 1. Well, again, it's not a 1 in this case. Whatever number that is, you have to factor that out front. You only factor it out of the x terms as well. Negative 4 is not going to change. It's going to stay negative 4. Well, if I factor a 2 out, I'll have x squared plus 6x inside of the parentheses. Because again, 2 times x squared is 2x squared. 2 times positive 6x is positive 12x. Again, my minus 4 is still hanging out. So here comes the completing the square portion. Now it's like what we did before. So I have my x squared plus 6x. I'm going to throw a number inside of the parentheses that wasn't there. And again, this one's things are going to change a little bit because of this coefficient of the 2. So whatever number's in front of the x, we take 1/2 of that. So 1/2 of 6 is 3. Then we take that number and square it, and that's what goes back inside of the parentheses. So I'm going to throw in a plus 9 that was not there before. Okay, now this is where we also have to be a little careful. If you just subtract 9, that's not going to be correct in this case. Again, it all depends on this coefficient out front. So let's multiply out what we have right now and compare it to what we started with. So if you multiply 2 times x squared, well, you'll have your 2x squared. 2 times 6x, you'll get your positive 12x, which is good. I've already got a negative 4, which is good. So the extra thing is going to come when I multiply the 2 and this positive 9 that wasn't there before. So if I multiply 2 times positive 9, I'm going to get positive 18, but there's no plus 18 in this original problem, my original equation. So to get rid of the plus 18 that's going to result, I need to now subtract 18. Okay? So the moral of the story is, the moral of the story is whatever coefficient is out front of the parentheses, multiply that by the new thing that you threw in there, and then you're going to have to subtract that away. Okay, so again, play with this, multiply it back out if this step is a little confusing to you, and see that in fact you do get the original thing that you had to begin with. Because that's all we're doing. We want the same thing back, we're just changing how it looks a little bit. Alright, so now we can write this in vertex form. So my 2 is out front. X squared plus 6x plus 9, well, how does that factor? I think it factors as x plus 3 times x plus 3. And the trick is, when you take half of the number, whatever that is, in our case it was positive 3, that's what's going to go inside the parentheses. So if you end up with weird fractions, you can basically just plug that number right in, and that's how it's going to factor. So just a little shortcut. So x plus 3 squared, negative 4 minus 18 is negative 22. And now we have written our original quadratic equation that was in standard form. We now have it in vertex form. So one last time, the vertex of this parabola would be at negative 3 comma negative 22, and it would open upwards because of our a value of positive 2. Okay, so again, you know, I picked relatively nice numbers in these examples, hopefully to make it clear. If originally we had an 11x, well, when you factor 2 out of 11, you would have 11 over 2, then you'd have to square that, and then things would start getting pretty tedious with fractions. But again, the procedure would be exactly the same. So again, this is the trick on completing the square. I hope it makes a little bit of sense. I know it can be a little tricky, but follow this little recipe, and again, with the exception of having some weird numbers, weird fractions, this procedure will work every time. So good luck. I hope this makes some sense. Again, I know that completing the square is confusing for people if it's been a while since you've done it, or certainly if it's the first time you've seen it. So don't get discouraged, just keep practicing, and again, just look for the procedure and just try to recognize that, hey, I'm really doing the same thing every time here. So good luck.